Alright, here's a slightly more complicated version of what we just did, where we tried to get rid of the square root that's in the bottom of a fraction. So we're going to follow the same procedure, but you're going to see pretty quickly why this one's a bit more complicated. So the way we began last time is I want to multiply by the conjugate of the denominator. The conjugate means just change the sign in the middle. So rather than having 2 plus 2 square root of 3, I'm going to have 2 minus 2 square root of 3. And I'm going to multiply the top and the bottom by the same thing. And if you've watched the previous videos, you know we've talked about the power of the conjugate and how that helps us get rid of the square root if we multiply something by its conjugate. So you can probably already see why this one's going to be a bit more complicated. I have 2 of these multiplication problems to do. So basically 2 multiplications in one. So I'm going to go ahead and do 2 box methods for this one. I guess for the top, I'll start with over here. So on the top, and remember, box method is just one way to do your multiplication. If you can do this in your head, or if you like to do this using FOIL, whatever, any of those processes work out just fine. So I have 4 square root of 2 plus 5 being multiplied by 2 minus 2 square root of 3. Okay? Remember that when you do this process, numbers that are outside of a square root will multiply together, and numbers that are inside of a square root will multiply together. So this first box becomes 8 square root of 2. 5 times 2 is just, of course, 10 for this box down here. Moving to the bottom row, 4 times negative 2 is a negative 8. And then multiplying the square roots together, I get a negative 6. Or, I'm sorry, a 6. And then finally, 5 times negative 2 square root of 3 would be negative 10 square root of 3. Looking for any like terms to add together. To be like terms, you need to have the same radical in this case. None of these have the same thing, so let's just go ahead, I guess, and list these pieces all out. It doesn't really matter what order you're in. I'm just going to write them down, I guess, in this order. I'll put all my radicals in front. So 8 square root of 2, I've got a minus 8 square root of 6. You would need the same number inside the square root to be able to add anything together. So none of these pieces can be added, and then that plus 10's at the end. So all of that becomes the top of my fraction. So I know you might be thinking, like, our whole goal is to simplify this to make this answer look simpler. And we're already looking way more complicated. But remember, simplifying really just means no square roots in the bottom. It's not necessarily going to look simpler when we're done. All right, we're about halfway through it, so take a break if you need one. There's the top multiplied together. Let's go ahead now and multiply the denominators together. Now remember, this is where we use the conjugate, so this is where square root should cancel out. We obviously did not have square roots cancel out in the numerator, which is fine. You're allowed to have square roots in the numerator. But when you're done with this step, there better not be any square roots left. Otherwise, something's gone horribly wrong. So let's see, where was I? Negative 2 square root of 3. So let's go through and multiply this together. 2 times 2 is, of course, just 4. Next box becomes 4 times the square root of 3 when you multiply numbers inside and outside together. Bottom box becomes negative 4 square root of 3. Hooray, that's good. Remember, those are supposed to cancel out when we add these up. And then finally, for your last box, be careful. When you multiply the numbers outside, 2 times negative 2 is negative 4. And multiply the numbers inside the square root, that becomes square root of 9. And of course, square root of 9 is just a regular 3, so this box is really just negative 4 times regular 3, which is really just negative 12. And so when I add all this stuff together, we've already said those boxes have canceled. There should not be any radicals left over when you're done with the denominator multiplication. So you get 4 minus 12, which works out to be just a negative 8. When you multiply something by its conjugate, it should work out to just be a single number like that. So if I take that all the way back up here, remember that was the denominator, and so I end up with this incredibly awful looking answer, which we're not done with yet, but that's considered simplified because there's no radical in the bottom. So one last thing to do, and I said that's why we're almost done with this, is you always want to check, look at every single number that's not in a square root. 8, negative 8, negative 10, positive 10 at the end here, and then negative 8. And it's rare, although this time we were lucky enough to have it happen, where if all of those numbers, and it's all or nothing, if every single one of those numbers can be divided by the same thing, then you have to go through and divide those numbers by the same number. So what I'm going to do is I'm actually going to divide everything by negative 2. And the reason I chose negative 2 is simply because I wanted that bottom to work out to be positive. You don't have to do a negative 2, you can do a positive 2, but whatever. All that's going to happen is divide everything by 2 and change all your signs around. So this becomes negative 4 square root of 2. All the numbers outside, all the numbers I just wrote over in green are getting divided by negative 2. So plus 4 square root of 6. Notice the numbers inside the square root are not changing. Plus a 5 square root of 3. and then finally a minus 5 at the end. And when I divide that bottom, negative 8 by negative 2, I end up with a positive 4, which was my goal. And so this monstrosity is actually considered my simplified expression. I know I'd be the first one to say there's no way that looks simpler than where I started, but what is simpler about it is it does not have any radicals in the denominator, which was our goal.